I'm Jack Rusk, C.Scale. We build whole life carbon tools for architects and engineers, and our goal in the industry is move projects and practitioners who would not otherwise be doing this analysis into a position where they can contribute to climate solutions. The decisions made by engineers, architects, designers, and planners every day literally move mountains. The networks of resource extraction and material movement globally, right, happen at the stroke of a pen or the drawing of a line, right, in the design documents. And these small choices that we make have really far-reaching material consequences for the social world um, globally, as well as the ecological world. So just like our decisions we make can contribute to negative outcomes through these supply chains, we can also make positive decisions, investing in regenerative choices while also minimizing the use of scarce resources and even bio-based solutions that might have land use impacts that outstrip maybe some of their climate benefits. We see life cycle assessment and really specifically whole life carbon assessment as the tools that allow any given practitioner to tell the difference between negative outcomes and positive outcomes from the choices they make day to day. One thing that I think is always really important to remember in this discussion, again, is that designers have a purchasing power and therefore a power in their decision making orders of magnitude higher than an average consumer. So I might make the choice this year or for my entire lifeline, say, to eat a vegan diet or only bike to work. But the decisions, a person might make detailing a shade assembly or designing a curtain wall can have, in just the way that detail gets drawn, many lifetimes of positive impact in the way it's able to reduce material use and supply chain emissions. And this really, I think, is an important thing that we as an industry need to hold on to, is the power that we have in the decision making we make every day to shape these decisions. We see, though, in the sort of current landscape of solutions available, tools will say that are sometimes described as like needing multiple engineering degrees to even get started, right? And we really are looking towards building workflows that allow designers and people who are not otherwise lifecycle assessment practitioners to participate in these decisions and improve building outcomes through the use of data. We do this by establishing reasonable guardrails, building analysis parameters that reflect the real world, not an idealized world, and by packaging all of this into easy-to-use user interfaces, used especially these days actually in higher education as teaching tools to help the next generation of practitioners become fluent in low-carbon design. We see this as a really important mechanism towards scaling these practices for the next generation of designers in the industry. So taking a whole life carbon approach also means looking at a very wide solution set, balancing operational carbon with embodied carbon, looking at landscape effects and refrigerant leakage. We're seeing in certifications like LEED v5 the move towards a whole life carbon approach. And we feel like this is essential to avoid some of the burden shifting that happens when people are working in silos, only looking at embodied carbon or only looking at energy use, and really trying to build tools to bring these together so that the people making decisions can do so with the full decision environment in mind. We've been working with designers globally on these tools, and it's been really a joy actually to work with these firms. If there's anybody from these firms on this call, hello, great to see you. In addition to all the firms we're working with, we've been really happy to support Autodesk in deploying the C.Scale model as a native integration within Autodesk Forma. We also work with large equipment manufacturers like Schneider and real estate trusts like Galvanize, all towards the purpose of scaling their climate impact globally. So many workflow tools that you see in the industry have this sort of like simplistic conception of projects as this linear flow from concept design through construction administration. We learned this in architecture school, but then as soon as you get into practice, you realize that the reality of projects is much more complex and much messier. And you see that many of the ways that the McLeamy curve is drawn, it really is this nice march from left to right. But the reality of projects is that they're much less linear processes. You design to a point, you value engineer back. You design the structural system all the way through to detailed drawings. But the interiors are still, like barely sketches and look and feel boards. So really trying to balance these different level of resolutions and this, we'll say, non-linear process that most projects are subject to is really what we're focusing on at C.Scale, is building tools to support the messiness of real projects. Um, we do this by moving across many levels of resolution and very crucially, trying to work across levels of resolution, especially when data is available at differing levels of resolution. It's very often that you'll have a very detailed structure and enclosure module, but site and interiors will lag. Or you'll know so much about, like if you're doing workplace, about the look and feel and the materials used, but there's an MEP upgrade floating around the edges that you don't know that much about. So the ability to work in different categories and different levels of resolution to ensure that at every phase you're making good decisions. This is really what we're excited to support across all these firms at C.Scale. Because the reality is that current tools are often built to highlight decisions at later phases once data is available. We've been really working for the last 5 years to move decisions left by filling in predicted data along the way so that designers can make directionally accurate decisions. And we've been really excited to see these approaches to highlight earlier whole life carbon decision making catch on across the industry. And I think that's really highlighted by some of our collaboration with Autodesk and Schneider Electric and other firms across the space. So early phase decisions, Amar said this, Cesar said this, Nathan said this, is obviously really where the sweet spot is in terms of influencing outcomes, but it's also when the least data is available. And that's why us, like others, are using data-driven approaches to do this. We're really, there's another talk to give that's much more in the weeds about how we build our kind of data infrastructure. We're really big fans of what we call small models. So not big transformer models, but very efficient GBM and SVM models and the orchestration across many versions of those instances to build model pipelines that can make reasonable predictions even when data is scarce. And this is something we've been really refining, not only in terms of how these models predict things like quantity data before the building is designed, but also how to run them very efficiently so that we can run them on CPUs instead of GPUs. There's a lot of, we'll say, like natural language processing happen now, where you might accidentally ask a AEC specific chatbot how to bake a pie, and it'll give you instructions for how to make an apple pie. This shows that like some of these tools are leveraging resources that are not scaled properly to the question at hand, leading to resource overruns upstream, in data centers, et cetera, as Nathan has illustrated. I think there's really something important when we talk about machine learning and the use of these data science approaches to find the right tool for the right job, right? Which often means we're not using general purpose models, again, because the resource consumption, et cetera, is sort of off the scale. With this, one thing we're really excited about, I think Nathan highlighted this really well in his presentation about IESVE as well, is supporting scenario-based decision-making, the ability to look across many options, find what's best, evaluate trade-offs and differences between ways of approaching a project, because this is really like what it comes down to in the end. Like the designers are often interested, we'll say, in what the carbon number is for a project. This is important for reporting and compliance. But when you're really trying to make a decision, you care less about what the number is and more about the difference between two numbers and how those numbers change over time and the trends in the data and the patterns. And this is really an exciting space, I think, to be in generally in data science, because it requires really like a thinking on the margins and sort of a thinking in the first derivative, right? You're less concerned about just getting the number right, but more about getting the number right and how it changes to ensure that the decisions you're supporting are directionally accurate, even if the order of magnitude is uncertain because you're at earlier design phases. As mentioned previously, we've been really excited to work with the team at Forma. I think there's a lot of ways that we are thinking about the resolution of models and the way that people move through design phases forwards and backwards that gives us a lot of nice overlap. And it's been a really, really kind of inspiring collaboration with the team at Autodesk. So with that, I know I've been speed running through this presentation. I'll stop there. Thank you all so much for sticking around till the end to hear this.
Wonderful. Thanks so much, Jack. Let me turn the screen off. So we actually started a little late. So thanks for staying a few minutes more, 5 minutes. We are missing Amar. So I have a quick question for all of you. I would love to know, and I'm sure our audience would love to know. Jack mentioned some of the companies. I